All right, we're working on our Atlas affordable stuff again today. I've got the turret lathe set up. Now this is for split cotters for on the Atlas mill overarm supports. Any place that uses a split cotter on the Atlas lathes, they use them on the tailstock. Where else do we use them? We've got a split cotter on the foot of the 7B shaper. Any place that's used a split cotter on the Atlas machines, the mill, the lathe, the shaper, this is all the same split cotter. Originally these were made out of Zamac. I actually prefer Zamac a little bit better. I think it works a little better for this application than aluminum. I think it's a little slicker, I feel like. So maybe that's not true, but you know, I feel like that's a better material for on the split cotters. I think they release a little bit better. And anyway, neither here nor there. We're making them out of aluminum, and this is, I guess, in direct competition with the big flea bay sellers that are selling them for $40 for a pair, or for a set, one upper and one lower. I think that's pretty expensive. So I'm going to show you my setup. We'll let the turret lathe, I'll run the turret lathe a little bit on camera just so you can see it running. I'll kind of explain the setup. And the same principles, the same dimensions are going to be applicable if you're turning it on your standard little Atlas lathe, which you can do just as easily at home and relatively cheaply. The only difficult part about this is going to be the square hole in the bottom. I think for this run of them, I'm going to set them up on the milling machine and go ahead and mill out that square for them. I previously did a video, and I'll throw a card to it up here in the corner, that showed how I just drilled a hole and then pressed in a hex bolt. So that works too. Would be perfectly acceptable on your machine, you know, but traditionally they had a square hole broached in the bottom. Well, it was out of Zamac and it was cast in a permanent mold. So originally they had a square hole cast in the bottom of them. Now I'll be making 3 different variations of the same part with setups on these because they use three different pieces. So this particular one's off of the milling machine for the overarm support. And the way they did it is the bottom piece is just like this. Hopefully we can see that. It's got the angles on the sides. I'm probably going to machine these angles. I'll set up a fixture on the milling machine and just cut those there. And I'll show you all of this when we get that far, but today we're just turning the main bodies. So anyway, this is the bottom portion. It's got the square hole in the bottom of it. So that's 3/8 of an inch deep. Length on these, I've measured several different ones. I'm getting a measurement any place from 0.650 to about 725. So a little bit of variation. It really doesn't matter. There seems to be enough room in all of the holes, or they're bored all the way through, to where the length is not super critical. You want to be fairly close, but that's about all that's really necessary for dimensions. Now on the on most of the applications, they've got this part on the bottom, the exact same part without the square hole in the bottom, or whatever sort of style hole you've got. They've all got a 1/4 inch hole through them. So this will be a bottom, a top will be the exact same part for this application off of the turret lathe. When I go to finishing them out, the machined ones will be the bottom parts. And then there's one that is just a cylinder with a 1/4 inch hole through it, and that's the only place I found that is on the milling machine in the overarm support. And what they've done, since that overarm support is a round piece of steel, is it's got the bottom portion on there, then it's got a little rubber spacer which has got a little cutout in it. This one's split, and it may be just because it's so old, but anyway, they've got a little cutout to clear the bar going through and to kind of match up with the bevels on here, both on front and back. And then there's the flat port, or there's another one of these inverted on top that doesn't have the cutout in the bottom. And then on the milling machine overarm, they're long enough to where there's another just straight cylinder that goes on top, and that's just strictly a spacer for on the top, and then the lock nut goes on top, or the adjustment nut goes on top. So that's the way we're going to do it. I'm going to use the same setup on the mill. For the top and bottom section of this original one that would be for most things, it's just they're both made exactly the same in this operation. Well, no, they're not. No. Okay, the bottom portion is going to be chamfered, center drilled, and then it's going to be drilled a round hole in the bottom to start out this square cutout. The next section on top is going to be just a cylinder without the hole bored in the bottom, and then for the top part on the milling machine, we're going to do the same thing. We're just going to make a straight cylinder too. So a third of the ones that I cut today will have an extra hole drilled in the bottom. So anyway, I'll show you the setup here. I hope that makes sense. I've got you back far enough, and I still don't have a good setup here for videoing on the lathe, but I've got you set back far enough so I can operate all the controls without any interference. So on this setup, I've got my collet chuck on here, 5/8 collet in it. This is the 5C collet chuck. This is about the fastest way I can produce stuff on this turret lathe. And once this lathe is completely converted over to a turret lathe, it'll probably live with this chuck on it. I've got my cutoff on the back, and I've got a chamfer tool that will chamfer both the front and the rear edge on this. On the turret tailstock, and I've got a couple that we're not using here, so we're just going to rotate through them. This is my stop, or this will be my stop, and this is my length set. So we're going to run that up to a stop. We will loosen up our collet chuck here, feed our material through, tighten that down again. We'll go to our center drill, which is our next operation, and for right now I'm just lubing with a little WD-40 on these. There again, this whole set of operations can be done on a manual lathe just as easily. It's just since I'm going to produce a bunch of them, why we're gonna run it. I'm not going to push this too hard. You know, I'm just kind of diddling around here. It took me probably a little over an hour and a half to actually get just the 4 tools that I've got here in adjustment. Well, the 6 tools, because I've got the cutoff and the bevel tool and the cross slide. Now both this cross slide and this tailstock they're not Sheldon parts. These are parts that I bought off of Fleabay probably years and years ago, and they both got adapter plates. They've got cast aluminum adapter plates underneath them that I cast and machined to set these up on this lathe. So it's all, other than the machine, the attachments themselves, the adapters are shop built. And they work just fine, you know. I mean, they do a good job. I'm sure when I redo all of this stuff, when I get back to redoing this lathe, why we'll go ahead. Now our hole's bored all the way through. I'll go ahead and rework all of these, clean everything up, and make a few improvements to them. Now we're going to counterbore part of these. Actually, I'm going to counterbore this whole section of pipe that I've got. This cutout's 3/8 of an inch deep, so I'm a little shy with that since I'm going to do these. And that's all the machining on the tailstock. Then we're going to start our cutoff here. Then we're going to bevel both the front and the back edge. The back edge of the one we've already drilled, the front edge of the one that's coming up. And we'll finish parting it off. Now we'll have to knock the little burr off the back end. But anyway, there's our part as it comes off for that section. So a little bit of deburring on the back end, and we're good to go. So we bring it back up to our length stop. And of course, with like all drawing collets, it draws it back a little bit, so I've added a little extra to be able to accommodate that. Now eventually, probably by the time I do the next run of these, I'll have a rotary broach, and we'll just go ahead and broach that probably in this next, in that next position. That'll probably eliminate about, 4 or 5 minutes per unit. And that's it. Rinse and repeat. Come on. Get around here. There's the way they look right off the machine. Looks like I better give them a little more bevel right up front. That was the first one I did. Yeah, let's add just actually that's an alignment issue with cutoff, I think. Yeah, let me make a little bit of an adjustment here. All right, well, I had a tool bit shift, so I had to readjust for my bevel. When I did that, I ultimately ended up and moved the whole tool post, and that didn't, but it could very easily have created some interference between the turret tailstock and this front tool post. So we've got that taken care of. We've got everything realigned. I think we're ready to go here. So we'll run a few off from this view. I'll move the camera around so you can look down on it a little bit more. I don't know if I can get you a good spot that's gonna not interfere with me operating, but we'll see what we can do. And we're just gonna let this run for a while. So anyway, this is pretty applicable to anything you're gonna do in your own shop if you're going to build these. Like I say, you're going to adjust your length, you're going to drill it 1/4 inch, you're going to counterbore if you're going to do it the same way I'm going to do it with. This is a 13/32 is what the bigger counterbore is. You're going to bevel the front end slightly, bevel the back end slightly, and that's the portion there. Now you can go ahead and cut your square hole in the back just by using a tool bit and your standard tool post and use it as a broach to cut. I'd set a length, and you know, if you're interested in seeing that, well, I can probably set up and do one of those here before too long. But that's the setup. So sit back, enjoy the show. Hopefully you find this a little bit interesting. If you do and haven't already, I'd appreciate if you hit that subscribe button. If you hit the bell notification, you'll know when I put out a new video. Comments or suggestions, leave them in the comments section for me below. About 2 minutes and 10 seconds is about what cycle time is on that. Burr to clean up off the end. Got to cut a hole in the center, otherwise we're good to go. Sticky coming through that collet. Really not necessary to center drill this. I left enough of a nub on the end. It just makes sure that there's we're still centered up rather than having that drill bit walk off a little bit, maybe when we started the next one. Well, that's enough of that foolishness. I'll bring you back when we've got some parts to show you. Okay. Well, here's we actually have a whole little tub of these. These are going to be the bottom portions of the split cotters. And set them over there so they're out of the way. And we'll machine a couple of them here on camera so you can see the way I'm machining them. These are the first couple. I already got the squares machined in them. Now, as I said before, these are 3/8 of an inch deep in there, and I was not sure exactly how I was going to cut these. I ended up, and I've run a 3/16 end mill down into the bottom of these. The offset, I've zeroed them out, and I'll show you the setup on the table here in a minute on the milling machine. The setup was I've zeroed out the center bore, because the way they were machined on the lathe, I just drilled a hole in the bottom of them, knowing that I was going to mill them on out. So that gave me basically clearance, removed the majority of the material. And I wasn't sure exactly how I was going to do it, if I was going to set it up in the rotary table and machine out one corner, rotate it, machine, you know, and go through all four corners that way. What I ended up and did is I just centered it out, zeroed it, and I'm just offsetting it a eighth of an inch in each direction from zero. So I've got a pocket that's basically a 1/4 inch square. I've used a 3/16 end mill and just pocketed them out that way, so you can do the exact same thing. Another way you could cut these would be to broach them on either your lathe or your milling machine, just with a standard lathe tool bit. You know, if you've got a 4-jaw chuck set up on your lathe, you can index to each of those four, have each of those 4 jaws come to a known point or a known stop, and then just broach them out like you would anything else. Just use a tool bit as in your cross-sliding compound as a shaper tool, and just shave that out a little bit at a time until you get your square. Now, the way I will run the next batch of these is I will have a rotary broach, and we'll just broach out the squares in. That's going to be the most efficient way for me to do it if I'm doing a production run of anything. So let me show you the setup on the table here real quick. Let me clean it off and we'll get this going. All right, now all I've done is I set up my rotary table, zeroed it out, and then I zeroed out the 4-jaw chuck on top. Like I say, I wasn't sure if I was going to rotate it through using the rotary table or exactly how I was going to do it. It was easiest just to offset them. I just used a little square that I've got as a stop, because it could foreseeably go in. Now I've got my little Noga cool on here, my little mister. I'm not a real fan of these little Nogas. I've got 2 of them, and one of them set up on the CNC mill. The other one is, or this one is normally on my power hacksaw, on my little hacksaw. I don't really care for them that well, but they do add some lubrication, kind of frees me up a little bit here. I'm taking the air hose and blowing these. I'm not so much worried about coolant per se, but I'm more interested in chip evacuation. So that's the way I've set these up. I did, this morning when I was still turning some of these parts on the lathe, I did put this little Noga cool on there just to lubricate those a little bit, and it makes it a little bit easier there. But I'll link these in the description below. There'll be an Amazon link for them. I'm not real impressed with them. They were really the thing for a while, and I think they've fallen out of favor a little bit. They don't give unless you're wanting to put a fair amount of coolant out, they don't seem to be real consistent in the coolant and air delivery, especially coolant delivery. So I think there's better options, and I'll be doing some projects with that, because I want one both for this mill, and I'd like to have some sort of a mist coolant on the lathes as well. So there'll be some changes made, but anyway, for now it helps a little bit. So running a high performance three flute carbide end mill specifically for aluminum, and it does a really nice job. I really like the way they cut. So if I can get this set for depth here. Well, heck, I want to overshoot my marks on the digital readout as I'm talking here and not paying attention to what I'm doing. So this should be a little bit better here. There we go. So that's probably enough of this foolishness for you. I'll go ahead, I've got quite a few of these to do yet, so I'll go ahead and get these pocketed out, and then we'll come back and cut our bevels, and these will be just about done. And that's the last one. A little bit of stock for a while. That's all the ones I'm going to cut right now with the square hole in the base of them. Now there's a couple I'm going to have to go back as I sort through that when I do quality control. I noticed one or two of these that I didn't get beveled, so they may have been initial setup parts, something like that. So anyway, those look pretty good. Now we're going to break down this setup, clean things up a little bit, and get ready to cut our bevels on both sides here. Okay, I guess I should have explained the setup here just so you're following along with me. Just took my spin indexer, set it up at 30 degrees, which is what I measure out the bevels to be. And I've cut them by eye. Now, fitting on these, you may have to adjust them a little bit. I've intentionally left them just a little bit, that flat maybe just a little bit shorter than it needs to be. So, you know, you may have to break the upper edge or the edge where it goes through and lower it down a little bit, but I'd rather have a little more, have it be tight and have the angle set and have a little fitting done to it rather than have it be too loose and not tighten down the way you want it to tighten down. So all I've done, like I say, set it up 30-degree angle, figured out what I think my depth should be, and I've got a stop in the back. Now these are just the straight ones, they're not the ones that I bored the back end out of. And I'll have to reset my stop when I do that because the stop I've got in there will protrude up into the cutout. So we'll just readjust it once I get these done. We've got the square hole cutout split cotters, and we have the just tapered split cotters that are going to go together like that. That's the way they'll fit in your orientation for that. And if we would look at one with a bolt in it, these would be this is a factory bolt here, square head, they're 1/4 20 lengthwise. Now this is off of the milling machine, but these are 3.5 inch long bolts. That's what the shank length is, and then the head. And I'll be either producing a run of these or else we'll order a bunch and have them in stock. So anyway, the way they would go together on your tail stock would be just like that. Now on the milling machine orientation, you're going to have your bottom piece on, and this is a used one, but they had a rubber spacer on there, and I believe that's about 5/8 of an inch long. Yeah, I measure that to be 5/8 of an inch. And it would set on here, just like that. And then your upper goes on, and it acts as a spacer because that arbor support is quite a bit larger. So your arbor support, or your arbor, yeah, it's your arbor support. The bar sits right through there. So that's the way that goes. Then on the milling machine, you're going to have another spacer, which is the same as these other spacers, except it's just a straight spacer. Sets on top. And then your clamping bolt would go on the very top of that. So that's orientation for the milling machine. Now I've got to turn out a few more of these. The turret lathe is still set up, so we'll be finishing those up before I break that setup down. I'm going to do that here in just a few minutes. But in the interim, what I'm going to do is take what I've got done for production right now, and I think we're just going to rough tumble these, or we're going to abrasive tumble them. So what I've got so far is these are the ones with the square holes in them. These are the upper portions, and I can give you the numbers. But now, if you do purchase these from me, expect to do a little bit of fitting on them. The reality is, I think my dimensions are right, but I've probably left a little bit of material, especially in the beveled area. On this bevel, I set the bevel, but you may have to file a little bit of that down. Now, the reason being, I'm finding a tremendous variation on the different machines. When I put a set of these on my milling machine, and my milling machine's, it's been repainted, so it's even down in the holes, and it was pretty well finished when I redid it, so it's got a fairly thick coating of epoxy paint on it. So there's some paint, I'm sure, down in the bores where these set down too. These are tight in the bores on my milling machine. When I put them on, say, my Atlas Index headstock centers that I bought to use as a pattern to build my index centers off of, these are extremely loose in them. So I've also tried them in a 10-inch tailstock, and it fits kind of middle of the road there. So there's some variation in the way these different castings were machined for the machines. So I'd prefer to leave you a little bit of extra material for you to fit down and have it be a good fit. And in the future, I'll do a little video on setting these up and making sure they fit right and everything, and they'll release and that type of thing. So anyway, I think I've got dimensions right for you, but expect to have to make sure you may have to fit them a little bit to your machine. You know, I've taken out plenty of material. There should be no issue at all with fitting your square-headed bolts in these. So that doesn't concern me at all. But there's just variations from machine to machine and tolerance buildup. So just be aware of that. Nothing, I guess I'm kind of rambling on that, and I don't really think it's that big of an issue, but I do want you to be aware if you do purchase a set of mine. So I'm going to go ahead, we'll throw these in the tumbler and start them tumbling, and I guess they can all go together. So we've got a couple of sets of them that are going to be ready to go here within, about 3 hours. I'll probably let them tumble, and by the time I clean them up and then we'll probably go ahead, we'll final inspect them and bag them up, and they'll be ready to go out. So anyway, I'll take you out. I'll just show you my little tumbling setup. I've already got the media back in it and a little bit of lubricant in with it. So it's just a matter of dumping these in and starting them to tumble. So this is just my little tumbling setup. We've got ceramic media in it and a little bit of soap for lubricant and just a little bit of water. So it'll sit and tumble for about 3 hours, and this is going to get real loud real quick when we plug it in, so we'll just tone the audio down, and I'm going to dump them in, we'll let it circulate for a couple minutes, and then we're going to call it good for this video, I think.